Okay. Good afternoon, everyone, and welcome to a CIWEM webinar of AI use in the water industry, a water company perspective. I'm Lucy George. I'm a member of the Southwest branch, and I've been chartered with CIWEM for just over a decade, and so sit within that Southwest branch. We'll talk about that a bit later. There's still a few people coming in, but I think it's slowed down. Oh, now people have left. I don't know what I said. Never mind. Okay, we'll keep going. Will that move on? Oh no, it didn't. Oh, there we go. Okay, so some general housekeeping. This presentation will be recorded. It might take a couple of weeks / months to be within the CIWEM website, but it will be there eventually. So you'll be able to find it there soon. If you will have any technical issues, can't see the slides, or suddenly there's no sound, etc., please use the chat box, and Barbara can answer and help you out there. If you've got any questions throughout the presentation, please use the Q&A boxes. We may get a number of questions, I suspect, within these presentations. And so please use the upvoting function. So like it if you would like it to be asked. And then the ones with the most votes will be answered, just to make sure we get through the ones that are most important to people. Once our speakers start, I'll go on mute as much as I possibly can. And we won't take questions throughout the presentations, but we will do right at the end. For this webinar, you can claim an hour CPD, though no certificates will be issued. Okay. So CIWEM South Western Branch is a small group of volunteers. If anyone would like to be more involved, helping to arrange events, it would be appreciated. Please contact myself or Barbara. I think I've got my email will be in a slide coming up shortly, but it's lucy.george@ytlgroup.co.uk. You don't need to be chartered, but if you are working towards chartership, it could be useful. Please also contact us with any ideas or webinars, ideas for site visits, social events, or support with competency workshops, etc., because it would be really helpful to understand what you're looking for from us. So CIWEM as a chartered institution of water and environmental management, it's a global royal charity, and you can see the outreach from this picture in front of you. Within these slides, there's more information about CIWEM if CIWEM is new to you. There's also Barbara's email and my email on here. And then if our speakers are ready, happy, excellent. I just want to introduce you to Jody Knight and Fed Villa. They both work for Wessex Water and are going to enlighten you on how we're using AI within the water industry at the moment. Jody, as it says on the screen, is a specialist in water industry strategic and business planning with 23 years experience. He's also a mean guitar player. And Fed is a senior high-level assessment engineer at Wessex, and also incredibly creative with a small amount of geekiness, which he's very proud of. So I will leave the rest to you, if that's okay. Next slide. Sorry, you're going to have to. Thank you.
Sorry in advance, there's going to be a couple of comments on next slide. Well, good afternoon, everyone. I am Federica. I'm going to talk to you about artificial intelligence in sewer CCTV survey. Next. Just before we're starting, however, I wanted to make a small clarification about a difference between machine learning and artificial intelligence, because most of the time the two terms can be used interchangeably. However, there are two different, like while artificial intelligence refers to wider ability of computer to emulate humans and essentially like perform tasks in normal environment, machine learning is a small category of that broader concept. Well, there are like a machine or algorithm that essentially recognize pattern. They can make decision. They can also improve themselves. Next. How Wessex decided to look for artificial intelligence is like, we start with a little bit of background. Wessex Water owns over 30,000 kilometers of sewage network, and unfortunately we can only survey a portion of it every single year. There are several limitations, and the majority of them is essentially that each crew and van, they can essentially survey a very small amount of network every single day. And is also a very time consuming activity, as they're going to have to drive a small rover into the network, pan and tilt to identify defect, code them in real time. Sorry, next. And the question that essentially we wondered is like, is there a way to essentially increase the amount of network that we can survey for essentially the same amount of money? Next. And this is how a marketplace challenge started. So we just inquired, and over 20 companies essentially answer back. And of these 9, we decided to essentially test it further. And in the last stage of the survey, we decided to bulk upload the 5-kilometer footage. This footage, they included several defects of different grade and different category. And not only we provided pan and tilted survey, but also drive-through sewer, which essentially they can be recorded at a slightly faster speed. And just we wanted to see what was the result. Lucy, next, please. We didn't have any expectation, because we didn't set any expectation of what we were looking at. And for who is not familiar with CCTV survey, a CCTV survey, we usually looking at structural grades and service grade. So essentially the structural condition of a pipe and what is in it that may impact serviceability. And each single defect is then graded from 1 to 5 according to the gravity of it. So as the graph may be slightly intuitive, it's like we just wanted to compare what the operator versus the AI was recording for the same amount of for the same survey. And ideally, we wanted to find the algorithm that is kind of like best matched between operators and versus AI. That one that you see there is just a representative samples of one of the many surveys we review. Lucy, if you can press next. Once we decided to go for, we identify a suitable CCTV, a suitable algorithm, we decided to use as business as usual. And in just 6 months of adopting it, we noticed that we managed to double the productivity of our crew. That also led to allowing us to expand the proactive survey program. So we had better knowledge of more of the network. We were essentially on site way much less, and help us also like to have a better knowledge and of what was happening in our network, alongside several other benefits. Next and next, please. And that is the only question that we kind of had at the end of it. It was like, AI can replace machine, and AI machine learning can replace human. And in Wessex, in this case, we decided that it was not the case. It was like machine learning are a tool that help to enhance our resources. We are not going to replace the human experience, but we are just going to support each other and kind of like use as best as we can everything. Thank you.
Right, on to me already. Okay, I'm going to talk to you about a couple of other instances of where we've been using AI within the water industry and Wessex Water. I have to say, Lucy, it's bass player, not guitar. I don't play guitar. Bass is far better. Anyway, next slide, please, Lucy. Yep, the areas I'm looking at here today are how we've used AI in an operational environment, but also how we use AI to support customer decisions as well. So the operational use is about how we look at event duration monitors, so our storm overflows, and we've now started rolling out in-sewer monitors as well, so low-cost monitors that go into manholes. And we get a lot of data from these monitors, make sure we use that data better. And from a customer perspective, we're also looking at how these overflows impact the open water swimming and river swimming that we have in the area, and what that could lead to in improving the way that customers make a decision whether they want to go swimming or not. Next slide, please. So the reason we chose to use AI in an operational environment is it was out of necessity. We had a regulatory driver from the EA to install storm overflow monitors. We now have around about 1,600 of these EDMs, event duration monitors, in the network. And in 2020, when we went to do this trial, we had around about 650 live in the network. And at peak times, we were getting huge numbers of alarms. We set our alarm levels for overflows in a linear manner. So we weren't taking into account the impact of rainfall. So every rainfall event effectively caused an alarm or an alert. And we wanted to look to how we could reduce the threshold of alarms going into the control room, try and see the wood from the trees, and make sure that we were focusing our efforts on the key elements of data that were being sent through to us. So we've got 1,600 now live in the event duration monitor, and we actually have 3,500 in-sewer monitors installed at the moment, which are also going through our AI tool. And this AMP coming, we're planning to install up to about 12,000 of those low-cost monitors. So as you can see, we're going to get huge numbers of amount of data coming back through that we need to manage that. We also have a very hostile environment. So in sewers, we get sewage slime and we get hydrogen sulfide. Both of those attack our sensors and the issues we've got there. So we get quite noisy data. So in-sewer monitors tend to have real issues in the noise in the data. We get things like benching. So an in-sewer monitor works through either radar or sonar, and effectively you get reflections which cause issues. And we wanted a system that could isolate or remove that noise from our data. Next slide, please. So we, again, did another marketplace challenge. So you've got a link for that in the chat. And we went out to a market and looked at around about 70 sensors in the Bath region. And we wanted to try and understand how a in-sewer monitor would operate in normal conditions and how we could isolate what abnormal operation would be, taking into account rainfall. And it looks simple. I mean, it really does look simple. You know, rainfall, level, just plug them together. I'm sure you could work out exactly how a sewer should operate. But in reality, what we were finding is we're getting huge numbers of false alarms in different providers, and the algorithms that were required had to be quite specific. So we go to the next slide, please, Lucy. So every single monitor that we put out there effectively has its own unique fingerprint. The catchment topography, how much infiltration that catchment has, whether the catchment is highly permeable or impermeable. So that affects the latency, so the speed of which rainfall falls through the catchment. We also have different sewer capacities. And in some instances, we get river backflow. So each sensor was unique in the way that the data was effectively calculated within the algorithm. That data, the algorithm had to be trained. So the model was trained, but it didn't use data such as the sewer level sewer level manhole, the hyperlocal rainfall data, groundwater levels, and river levels, and then also the catchment boundary. But it didn't use capacity or the wet well capacity. So it's purely a data-driven based model. And these models each individual model takes about 6 months for it to learn to be accurate enough to go live. Next slide, please. So that custom model for each site resulted in lots of wonderful things that we've been finding in the sewer network, including bags of grit. We found a flat valve in the trial alone, which was only for 3 months. We found 3 or 4 blockages. This is back in 2020, where we expected there actually to be a pollution event on the back of that blockage. And these models don't self-learn. We haven't got a self-learning algorithm with these. The trouble with self-learning algorithms that we found is that capacity-wise from industry, we don't necessarily have the resources to go and resolve the issues that aren't necessarily causing impact to the environment or pollution risk. So the model will retrain itself on the data that it's seeing. So if you have a partial blockage, and effectively the level increases slightly, we don't want that model to retrain on that partial blockage, because it'll become part of the norm. So we actually continually model and develop these. So when we get dynamic changes in the network, so for example, growth or maintenance, where we go and jet an area, we will then go and retrain that model after that to ensure that it's relearning based on the new normal. And we reflag that. But what we found was a bow wave of issues as we're going through this. So as we install monitors, get them up and trained and operational, we get lots of new alerts coming through. And then when you resolve those issues, we then have a bow wave of retraining those models to get them back to the new normal. Very interestingly, in Bath, when we did the trial, it's a testament to the value of AI for our teams, is we ran that trial for 3 months. We then switched that trial off. And within 2 weeks, I had the operational teams going back to us and saying, can we turn this back on? Because it was changing the way they were looking at the network and how that network operates. Next slide, please. So Wessex Water are seeing big benefits from AI models in operational use. We've in the last 3 years, we've had what we call over 150 good catches. Now, good catches are potentially a blockage or an incident within the sewer network that could lead to a pollution or an issue within our network. We've got operational teams better understanding those sites. They understand how the network works in more real time. We're starting to understand infiltration slightly better. And also we're changing our way we do some of our capital maintenance. So we're moving towards a more proactive approach. So where we start to see trending data in the way that sewer is operating or slightly higher, moving outside that envelope or window of normal operation, we can then go and push out jetting teams to go and resolve that issue before that problem presents itself. And we can change our what was fixed term capital maintenance approaches to a more intelligent, proactive approach. And that's more cost efficient for us as a company. And we can start to use our resources more efficiently as well. So resource management gets improved. We're also managing the way we look at pumping control systems. So the beauty of these AI tools is that it has the ability to plug into the pumping system and look at run stops. I'll go into a little bit more on that in a minute. So our confidence is improving. Our teams are understanding networks better, and we're seeing fewer blockages. In fact, where we've done this work and installed it, we're starting to see less return to sites to pick up blockages. We're identifying issues that might have been latent or legacy for a long time, and we don't need to go back to those sites so frequently. We also use the tool to monitor some of our sewage treatment works or water recycling centres, where we're analysing full flow to full treatment. Under the regulatory guidelines, we've got what we think called UMON 4, which means we have to pass a certain flow through a treatment works and not spill to the storm tanks. And we have the ability within this system to monitor that in real time and identify where things aren't quite right. We also have over 600 pumping stations monitored as well. And that's looking at pump performance indicators and doing some analysis on the run stops. What we're finding as well, we have issues where we have a pump that starts, but it has no impact on the total volume lost from that wet well. And the analysis is now picking that up. And when the second pump is called, it's flagging and saying, this is the only thing that's making a difference. So we're starting to identify faults and issues within our pumping network as well. But by far and away, one of the biggest benefits is we're looking at sensor health and issues that are related to sensors. So you can imagine with over 1,600 EDMs and potentially up to 12,000 sewer monitors going out, we need to have a really good understanding of how those devices are operating. We have a regulatory requirement for EDM to exceed 90% of those devices being operational at any one time. So, excuse me, having these devices in a tool that we can then monitor that health, flag when issues aren't working or these devices aren't working properly, means that we are actually Wessex Water, the leading company around EDM uptime. We're running about 96% of our devices operational, and that's purely because you can visualize the data and information related to these devices more clearly. Next slide, please, Lucy. Don't take just Wessex Water's word for this. Storm Harvester, who we work with and who won our marketplace challenge, are now monitoring. They've got over 230,000 sites across the UK, and they're taking in 2.5 million data points an hour. It's huge, huge amounts of data. And across the UK, we're seeing from 8,000 blockages confirmed by operationals per year, average savings of up to 8.6 million across the industry, and showing a massive reduction in what we saw around alerts. Wessex Water, we saw around about 94% reduction in alerts from using these devices over our threshold-based approach. And as you can see, if you look at the little picture there of the yellow dots, that was our trial back in 2020. And we were the first to roll this product out across the UK, well, in our region. And now you can see that it's grown to 230,000 sites. So it's in 5 years, AI has rocketed when it comes to wastewater networks. We've also got a couple of other additional elements that are coming through in development with Storm Harvester, and they're working with us and other companies to look at how they can identify inflow and infiltration and direct resources like the CCTV surveys that Fed was talking about to the right locations, avoiding pointlessly CCTVing sewers that have no infiltration issues or lots of staff walking upstream and monitoring manholes. So there's real improvements in the way that we're using these monitors and this data to improve the way that we work as a company. Next slide, please, Lucy. So the other case study I've wanted to talk through is about customer bathing waters and using AI in monitoring those bathing waters. So one of the big challenges we have around our bathing waters is monitoring E. coli and intestinal enterococci. So those that are harmful to health for humans. And historically, we've manually sampled near our outfalls and overflows and continuous flows. But these samples take time to process, maybe up to a week sometimes. And that's too late for swimmers. They're not getting real-time data about whether it's safe for them to swim or not. So we thought, well, can AI support us in understanding near real-time alerts for water quality monitoring and give those swimmers a choice whether they want to go swimming or not? Next slide, please, Lucy. And to support that whole process, the EA have asked us to start to monitor upstream and downstream of all of our overflows and our continuous flows within the river networks. So we are starting to install lots and lots of in-river monitors. And these monitor dissolved oxygen, pH, temperature, conductivity, reduction oxidation, and turbidity. And samples for these are typically taken every 15 minutes or every hour. And then we also monitor and take bacteria samples at the same time. And we thought, is there a way of using this data to infer a risk score or what likely levels of E. coli or i.e. have we got in that river at that time? So we again went to talk to the people in the market about that. Next slide, please, Lucy. And we ended up talking to a company called Unify. Unify took data from our sondes in the river. They took data from the Met Office, talking about rainfall levels and river flows. They looked at our regular sampling, the sampling we do, and then they also looked at our asset operation data, so overflow information, and they put this into their AI model. Next slide, please, Lucy. Now, I'm not going to go into the detail of this model. I've put it into this slide, so if you get access to these slides, you can go into the detail of how this calculation is done, but there is a lot of detail in how we trained these models to identify whether there's likely pathogens or E. coli, i.e. in that river flow at that time, using those indicator metrics. Lots of work's gone into it. It's way above my understanding and a bit beyond what I can talk about. So I'll let you read through it if you want to have a look at that. Next slide, please, Lucy. But the outputs is what I'm interested in, really. What we found is that we could actually get nearly 92% worth correlation using those indicator measures to give us an indication that there might be IE or E. coli present in that river flow. A huge benefit using basically a very low cost sensor or monitor and almost in near real time, giving the ability to flag and alert to customers that there could be it's not necessarily safe to swim. We would never recommend you swim in a river anyway. It's your own risk and your own choice to do that, but we can give you a support in your decision making. Next slide, please, Lucy. So we actually now have apps, and you can use the QR code if you wish to download that app. And this is at Whalley Weir in Bath, just outside Bath. And that app will tell you whether it's safe. We believe it to be safe to swim or not, and give you a choice of whether you go into the water or not. We'll be rolling this out to all of our inland swimming spots. We're doing similar things at Bournemouth around the pier to give people that choice of whether they go out into the water or not. And I think this is now being rolled out at a number of other companies across the UK. So we were a bit of a pioneer again for this one, which I do like to blow our own trumpet once in a while, but I think it's good to see that this is now growing and developing, and other companies are joining in that momentum, because it brings a huge amount of support to the rest of the industry, and we grow and develop so quickly on the back of more people involved in this capability. And I think that's probably is my last one as well, isn't it? I think yes. There we go. So plenty of time for questions.
Yeah, that is a lot more time than I was expecting. I was actually going to ask you, Jody, while people are writing some questions now, can you just go into a little bit about what Marketplace is and how Wessex use it and how people can access it?
Well, there you go. There is a website, Marketplace. I think it's in the chat. I saw it popped up, I think. Marketplace is a slightly different approach to procurement for us as a company. Procurement rules and procurement approaches tend to be very standardized and very locked into, this is how you have to define an output or define a requirement that you then procure against. We thought we'd try and look at different ways of using Marketplace to try and think about how do we solve problems, as opposed to how do we define a problem and then get that resolved. And we realized that we've got lots of data. As a company, we collect lots of data. There is a new approach around open data in the industry. I think Stream or one of the weird, I can't remember what the names are, but I think it's Stream that now is looking at open data platforms. And we chose to build our own open data platform. So Marketplace is an open data platform for us, where we define a problem, we pose a problem, and we present the data. And we then go out to market, go to talk to people, ask whether they're interested in being involved in trying to solve our problem. And we vet them, screen them, and they come through with maybe different solutions. And we have, for the Marketplace Challenge in Bath, for this in-sewer monitor stuff, we had 35 companies interested. We screened that down to 9 and then resolved that down to 3 that we took to trial. And of those 3, 2 were brilliant and 1 was terrible. I won't put names out there for the other ones, but it shows that you get a real variability in this case, and there's a lot of newcomers to the market. I think when we look at what's happened with the in-sewer survey one, the company that actually won our Marketplace on that, I think Fed were probably coming on this, but they were completely new to the market. They'd never done anything in sewer before. They were. Do you want to go through?
Yes, they were actually a mathematician and an informatic couple that they built their own company, and they had like no understanding of sewage network, and they built up the company from ground zero. So yeah, it was become like, they were brilliant.
So it shows that anybody can get into the market for AI and smart using if the data is available. and they've got an understanding of how that data could improve the use for a industry like the water industry. And this was that one was a true David and Goliath approach, because there was a company from Australia, I think, that had been doing masses of work in Australia and won some big contracts in Australia and parts of the UK. And this small company startup with 2 or 3 people, mathematicians and informatics, came in and proved that they could do it better on the results that we were seeing. So it's a huge advantage to be able to access data and make that data available, because those bedroom programmers could come up with something that that makes our life as an industry much easier. And we don't want to use AI or tools to usurp people or move people out of roles. We want them as a decision support capability, or to support people in their roles. Regulations getting tighter, we're getting bigger challenges, we're getting more and more data. We can't process that data humanly. It's just not humanly possible. So tools like this are the only way that we can progress and improve and use that data effectively. My biggest fear about the whole sewer network monitoring stuff is that somebody who had access to that data, because we've now got to publicize this data and make it published, could identify a problem in our sewer network before we could. Why can't we as a company be using that data more efficiently? And tools like Storm Harvester, Unify, they make that difference for us. When you look at our region, it's a big region with a lot of data. It's very easy to miss information if we didn't have those tools available to us. Does that make sense, Lucy?
Yeah, thank you. That's really helpful. And that leads on quite nicely to some of the questions that we've got. Andrew, do you want me to carry on with this, or you want it? Okay, there we go. Okay, well, if we just start from the top for it.
You're on a roll, you see, Lucy. That's ultimately, I'm more than happy to help you out, but you're on a roll and you're in it, which is great.
Okay, right, I'm there. I'm in it.
Really interesting, Jody, by the way. And
okay. Okay, thanks for the first presentation. AI may not replace humans, but humans without AI training appreciation also are not going to be replaced by AI trained humans. Oh, what? But are humans without AI training appreciation also not going to be replaced by AI trained humans? So I think what that's trying to say is, how can we ensure that the data that we're providing is supporting people rather than relying on AI, relying on it being used by people that don't understand the problem properly to come up with the wrong solution?
As I said earlier, I 100% believe that AI is a support tool. You still have to have the understanding, the network understanding, the ability to understand what you're looking at. When you look at some of the results we were getting from devices originally, there was potentially a lot of noise in that, and you need to be able to filter that information through. It's about making the problem this big to that big. That's what we see with AI. You can't replace that human element, not yet. Maybe in the future. One of my early slides around this was, will AI in the water industry be like Skynet? For those that have Terminator references, it's never going to get there. Not in my lifetime anyway. It's just going to be a tool that can make the day-to-day life of operators and decision makers easier.
Yes, even
Lucy, that kind of answers the second question that you got there from Freddie T.
Yeah. I think also, I don't think any water company would be using AI to try and reduce staff or reduce opportunities. There is so much more data and more things that we're looking at. It would be to get that efficiency to try and keep on top of stuff going forwards, is my understanding.
I see there's a dodgy bloke called Jay Millington on there who's just asked a question, who I know from a while back. He's asked a particularly pointy one to me as well, I can see.
Do you want to jump to that?
Yeah, I could go to it, Jay. It's lovely to hear from you. I haven't spoken to you in a long time. But yes, No, it's not our responsibility. It's still the swimmer's choice.
So
We're
the
offering.
question, just for anyone that hasn't caught up, because the chat moves around quite a lot, is there a huge risk of saying it's okay to swim when you're not 100% sure? Can a wild swimmer claim compensation if they get sick?
The point is we're not offering. We always say it's not safe to swim. You know, our view is there are other risks that happen in the water. We can't control all elements of the water network. You know, when you look at the catchment that feeds to Worley Weir, there's something like 1,500 individual sewage outflows into the catchment upstream. Some of those are private, some of those are networks. You also have huge numbers of animals, feces, birds. Western Beach seagulls, one of the worst things about the water quality at Western is the seagull feces. Wessex Water will never say it's safe to swim. We will just offer the ability for people to make an informed decision. So it's their choice. So no liability, Jay. So you can't make a claim against me.
Okay. And leading on from that, although Wessex Water will not advise people to swim or say that it is safe to swim, I will personally swim in Worley Weir. It's very lovely. But I would check the water quality first, water quality app. Okay, are Wessex largely looking to external suppliers to apply AI to your data sets, or are you doing any AI development within the company?
Shall we take this from Fed? Yeah, we're doing some internal work on that as well. We've got some teams in the IT department who we keep this data ourselves. We're running analytics ourselves. Whether it's AI, machine learning, you know, we have teams that work with this. We've got some outputs, I think, in the past that we've done analysis on. Not that close to our internal work. I've been mainly leading on developing the marketplace challenges and external. But we do have a team that are looking at this. And I guess the idea would be that if we can do it ourselves, maybe it will be cheaper. My argument also, though, is by having a hive of people using the same capability and apps and technology across multiple different industries or locations around the UK, you get an informed knowledge from the group. Whereas if you bring everything back just inside and train your AI based purely on the Wessex Water infrastructure, it'll only ever work for Wessex Water.
Brilliant. Thank you. Another one that's come up. Great presentation. Can you please talk about one of the main concern of using AI about cyber safety, specifically risk of data leaks or breaches, how to tackle these concerns?
I'll take this one as well.
Go for it.
Well, funnily enough, one of my roles within Wessex is also to monitor and overmanage the budget for cybersecurity at the moment. So I've got a little bit of understanding on this. It's a difficult balance. You know, customers want us to publicize and open data more. You know, bring more open data into the network. The challenge is what the risk is around a cybersecurity issue or a data leak. None of this is customer data. So when you look at this from a GDPR perspective, none of this will be customer information. We would never put customer data into an AI tool that is cloud-based or anything like that. It has to be measured and monitored. We have, through our procurement processes, every company does a cybersecurity questionnaire. There's a cloud cybersecurity questionnaire, but we try to avoid the whole GDPR issue. So customer data is not out there. Most of this data is purely just a level or a monitor or a flow. It's very low risk data to us as an industry. The biggest risk that we would have potentially if somebody spoofed that data. So, they basically went in, manipulated the data feed and showed us false results, which could lead to potentially a overflow operating without us knowing, potentially. That is a real issue. But I'm sure that most cybersecurity people have bigger fish to fry and more interesting targets to reach than a sewer overflow. So it's about the risk and consequence of that. The likelihood we think is quite low as well. So it's something that we consider. We manage. With a lot of the data we manage are over bespoke protocols, secure protocols. So, you know, it's a difficult challenge. Where we're using third parties, they have to conform to our cybersecurity rules. We vet them. We renew that every year, and we work closely with them to try and improve that.
Cool, thank you. How is AI utilised with the other SON parameters, DO, ammonia, etc., and how useful was it?
So the DO, and so at the moment we're doing trials around that. So the ammonia can't be measured in real time. It's ammonium, I think, can be measured in real time. So I'm right. So I think they were also included in the models. So probably didn't have them written down there, but they were also included. So they've all been used as part of that. The trouble we've got with DO is that when you move water from a river up to a location where you're doing your sampling, you often pump it, or sometimes you put the SON directly in the river, which is one option. There are options to move that water up to a different location. As you pump that water, it warms up and the oxygen dissolves out of the water, so you get a false reading. So we're doing trials at the moment around our Warminster, up and downstream of the outflow at Warminster, to look at how we change the pump routines to ensure that we maximise the DO. We get the coldest water coming into the sampling equipment, and we're doing lots of trials to try and improve that at the moment. It's an exciting industry to be in at the moment.
Thank you. How much effort do the company give to data management efforts to make sure, one, the data is of suitable quality, and two, company departments make their data discoverable?
I think this might be a different answer according to CCTV and Storm Harvester, because from like CCTV Survey AI, we already had a very good data management in place relating to CCTV survey. All our data is centralized and is accessible to the dedicated team that they're working on it. And even if like there was a problem on maybe the coding of the AI, we still will have access to the CCTV survey. So it will be very easy to record it and at the same time do Q&A. And whenever it's like we notice that there might be a problem, we can just go and query if there's been any iteration or any update on the algorithm that has been done recently, and we can essentially like look what goes wrong, because as I mentioned before, is this algorithm that we are using for CCTV AI is the machine learning tools. So get new information and learn from what has been given. So providing information that maybe a defect is not that kind of defect, or there is like any further information, the machine is going to learn from it. So all data is accessible and is already there. We actually try to integrate the AI to our system rather than integrate our system to the AI. But Jody, probably.
Are you on mute, Jody?
Yep, just realised that. I was trying to be good. I actually sit on a group in Wessex Water called the Information Management Steering Group. So we have a steering group within Wessex to ensure that we try and control and encourage data usage within the business. And I'm a data steward, so I look after telemetry data as my stewardship, and I oversee basically make sure that I'm support use of that data in the business. So we have data stewards, we have data owners, and we've started to allocate those across the business for different sets of data that come through. So we're trying to actually, make some form of governance process and control around that data use. We see the value of data. We think that data has a real potential to improve the way we operate as a company and make us more efficient. I think the days are gone of where you have your squirrel holding all of their nuts in one location, hiding their data from everybody else in the business because they feel it protects their livelihood or their job. We have to be more open, and we are pushing and encouraging the business to open their data more where it's available.
Thank you. There's a really interesting question here, which I will just do a shameless plug on the Planet Possible CIWEM podcast, because it covers this topic in a second. This just a couple of days ago it was released. other podcasts are available, but the CIWEM one is really good. It's brilliant. So if you get a chance to listen to that, please do. But the question is, AI and the subsequent data centres use a lot of water. Any thoughts of this from Wessex Water? I appreciate this is not in your roles, either of you.
Yeah, it's a tricky one, isn't it? Well, we have a net zero carbon target as well. So there's water and power, I think, is one of the other big issues about these big data centers. There's none in our region, so as long as it happens in Thames, I don't care. So
there will be.
So no, it is a really tricky one because obviously these data centers like clean water. They like water that's coming from the network. But I mean, potentially grey water solutions might be better, but then there's treatment processes that have to go in front of those. It's a big challenge. We haven't got any big water sensors in our region, but we are about to have one that, as Lucy will know, a massive battery factory being built in Bridgewater, which is also requiring a huge amount of water for that process. So a similar issue, and we're looking at grey water there, aren't we, or water coming from West Huntsville?
So I couldn't possibly say, and I think we should move on from that discussion quite quickly. However, you're right. There is certainly work going on within Wessex to look at reusing final effluent water. It's something we do from Avonmouth at the moment. It's not something that happens a lot, but it's if we're looking at circular use of water, then it's something that may well happen in the future. There's a lot of things that need to happen first. But yeah, it's a really interesting space of how we use grey water or how we use final effluent water from a property level up to a major industry level. And I know there's some data centers.
There was a big plant in the Olympic Park, wasn't there? Thames Water put a grey water and a black water treatment plant, which worked obviously and into legacy. Although I don't know more recently how that has performed, but interesting space.
But it would be a great webinar to do in the future on that as well. So there's some really interesting opportunities in the future that would be great for that, definitely. I know that there was something about data centers are planning to be built next to swimming pools, public swimming pools, so that you can circulate the water. I don't know how real that is, but that's an interesting look at it as well. So thank you for that. Okay, we've got a few more questions as well. So when you were selecting companies to provide the AI service to you, what sort of criteria did you use to help assess or judge the quality of the AI solution they could provide?
I can pick up this one for what we did with Storm Harvester. From the outset, we always set key metrics that we wanted to achieve. We set ourselves a target of what we thought was a good performance for any supplier from an AI-based approach. So it's about how do they deliver against those metrics and how do they perform against those metrics. Those metrics might slightly change as we learn the knowledge about through the whole process of what we did with Marketplace, but we still refine back to what we originally wanted to achieve, which was reduction in alarms by a certain percentage, no blockages missed effectively. That was the key element for us. And we were looking to do artificial blockages, trialing to prove and test that we didn't actually need to in Bath because we had so many anyway. So there was an element of making sure we measure it effect, and it does take human resources, quite a lot of people time to actually ensure that the most metrics are being monitored effectively. The other big area we found through a lot of these different products is usability, the visual platform, the functionality, and how people interact with that tool. It's all very well having really, really great capability, but if nobody can use it, it provides you no insight. So having that good user interface and the ability for people to feel that of different skill sets and levels as well can interact with that tool and get the data that's available to them is really key.
And if I may add, it's very customized because in our case, as I mentioned before, we were trying to integrate with our current system. So yes, having like a very intuitive platform, it was really useful, especially for like understanding what was like how the technology was working and so on. It was very useful, but at the same time, it's like we were also looking for integrability with what we currently have, and maybe in our case, we were not looking properly for like a user-friendly platform, more like support on both ways, or like make the system work all together.
Thank you. How does the AI tool distinguish bad data from good data to train the model for future predictions? And secondly, does the tool continuously learn and adapt? One of the slides states that the tool does not self-learn.
That was from my slide. Yeah, and it depends on what you're looking at. So the tools, AI tools, are made up of multiple different models, effectively, that come to a total solution. So the data cleansing element, Storm Harvester tool for data cleansing is extremely impressive. I could not tell you how it works. They have a number of algorithms behind their product that improve that visualization of the data, and they can provide you raw versus cleansed data in their visualization. It's incredible to see. I wouldn't know the detail on how they do it. You have to talk to the guys at Storm Harvester who will be able to support you on that. But on the self-learning element, it depends on the type of data you're trying to analyze. In sewers, self-learning would be a negative perspective, because you'll learn bad behavior effectively because self-learning. I've dealt with it on a couple of solutions around leakage as well with another product a number of years ago, in that we don't have the resources to go out and fix everything first time within 4 or 5 days or 3 or 4 months. So if you have a self-learning algorithm, depending on the frequency of how that algorithm relearns itself, it's very easy to miss issues or not log issues correctly, because the algorithm will relearn that bad data or that issue that you've already flagged. I think self-learning has its purposes in certain areas, maybe around the data cleansing. Probably actually there potentially is some self-learning stuff that sits behind that. I don't really get to see behind the black box of how they do that. But when it comes to in sewers, and I think even with faults within the visualization from a CCTV, they don't really change. So when you log something, you make sure you categorize it, and they don't really change. So having a self-learning algorithm might start to pick up things that we're not expecting, or we don't want to find effectively, or we're not really looking for. So we try to, it's a case-by-case basis. At the moment, with the instances we're looking at here, we're not using self-learning, but it might come with other cases in the future.
Brilliant. I think we've got time for one more question. Currently, the data is used internally for Wessex Water and other water companies to inform how the ground teams work with regards to blockages. Could there be a future where the data regarding sewage blockages or sewer blockages is used to alert customers of their risk of internal flooding, or that their area is at risk of continued blockages as a result of sewer misuse?
Absolutely. I think it's something that we could look to develop and improve on. We're at the beginning of this journey. It's been quite a challenge to get where we are now, and 5 years in this journey is not a long time. Everybody's learning. I know that if you were to go to Yorkshire Water, for example, they have a slight different challenges to us as Wessex Water as a network, in that they get a lot of people with cellars, and they get a lot of sewer backing up into cellars. And they have these little monitors that monitor every single property to understand where they're getting sewer backup. So there's advantages for them. We don't have the same issue in our sewer network, but sewer misuse is clearly something where we could start to look at localized blockages. The trouble you have with that is to be able to identify those, you need to have the sensors in the right locations and that density of sensor network to be able to make that data available, and that comes at a big cost. And sometimes the benefit of identifying localized blockages in small customer laterals or issues like that are outweighed by the cost. So it's a real challenge. How do we most effectively use the money that we've got to ensure the best benefit for every customer, rather than the 50 or so customers that might suffer a backfill to their household.
So I just want to jump in on that, because there is another question about regulators, actually. So do we have regulator support to use AI approach in water quality monitoring and regulatory reporting? Because how much money we've got available to do things like this will ultimately come down to the regulator, right?
Indeed, yeah. Well, the financial regulator, Ofwat, but the environmental regulator wants us to do more. So we're having to install these monitors.
Yeah. Okay.
So it's an offset really between a financial regulation, as we all know at the moment, because there's a Cunliffe report going on. We're looking at regulation in the water industry is a big challenge. We've got conflicting regulatory drivers around reduction in costs versus increase in scope, for example, with the in-river monitors. I think we've got good support from some regulators, but innovation in this industry is always a challenge, and the Cunliffe report is picking stuff up about how we find innovation to be a challenge. The Ofwat have an innovation fund, and the elements of that have come through with some smarter tools and AI, but it's about how do we make that available to all and deploy it across the whole of the UK. I think cases like this upstream and downstream monitoring of overflows and continuous flows is going to there's a huge amount of investment in this area. It's going to transform very quickly, and there'll be a lot of companies jumping on that bandwagon to try and use that data and help improve the way we access that information. And it takes these big regulatory changes to drive that behavioral change and encourage that investment in other parts of the industry to actually improve the way you use that data. So although it's a big challenge for us in that transition period, in the longer term, it absolutely improves the way we work as a company.
Brilliant. Thank you. I'm very aware of time, and I thought this might be the case, that we would speak at least during the answers for as long as the presentations were, which is excellent, and it shows a great amount of engagement, which is fabulous. So I just wanted to say thank you to Fed and Jody in particular. That was it's really interesting. It's obviously a huge amount of change that may happen in the future, but I think for the majority it's positive. So it's an exciting industry to be in, and it's an exciting field. I've left the slides up because there's just a few events that are coming up in the near future. And again, if there's more events that you are interested in either organising or want to just let us know you would be interested in, then send me or Barbara an email, and we'll try and make that happen for you. That would be wonderful. Thank you ever so much, everyone, for your time and for your engagement with this topic, and we hope to see you soon.
Thanks, Lou. Thank you.
Thank you.
Thank you.
Bye.
And Fed. Thank you very much.
Thank you.